Okay, let's say we have a capacitor of capacitance C naught, and we charge it. So here is our capacitor, and we charge it to a voltage V naught, and then we connect it to an inductor. Here's our inductor of inductance L naught, and we make this LC circuit. And we want to find the maximum or peak current. So find the peak value of the current in the circuit. Okay, so we know that if we solve the equations, the current looks like the amplitude of the charge, right? That's the maximum charge over the square root of L times C times the sine of T over square root of LC plus phi, right? That's the general solution. And so I peak would be this term here, which needs to be written in terms of known quantities. So the maximum value of the charge on the capacitor results from the values of capacitance and voltage, right? So the definition of capacitance is equal to the charge over the voltage. The capacitance in this case is C naught. So both of these increase or decrease together, but initially we have a voltage V naught and a charge big Q, which we're looking for, and that's the maximum charge that we'll get on the capacitor. And so we can replace this with this times this, and so we have C naught V naught for capital Q, and we divide that by the square root of L naught C naught. Yeah, but we can simplify this, right? This is C naught to the 1 power, and this is C naught to the 1/2 power. So this is C naught to the 1 times C naught to the minus 1/2. And so that just gives us C naught to the 1/2. And so I peak becomes the square root of C naught over L naught V naught. All right, we'll just take the positive root because we want the maximum value. Of course, we had to get this from taking a derivative of the charge equation. And the other way of going about this involves energy conservation, right? Avoid going through time, equations that involve time. And so here, all we have to notice is that for a fully charged capacitor, we have the energy in the capacitor is that charge squared over 2C, which in this case has to be written in terms of the known quantities C naught and V naught. And so we know what the initial energy is in the circuit when we connect the capacitor to the inductor. But that's also the energy of the LC circuit. That's the total energy in the LC circuit. So we can say that 1/2 times the capacitance, the inductance L naught, times whatever current we have squared, plus whatever charge is on the capacitor squared over 2 times the capacitance, that is equal to the total energy in the LC circuit, which we just found to be C naught V naught squared over 2. And so we want the value of the current, but not any value of the current. We want the value, the maximum possible value of the current. But when the current is maximum, there is no charge on the capacitor. So our equation looks like L naught I peak squared over 2 equals to the total energy. All the energy, in other words, is in the inductor at that moment. And so I peak, right, is just C naught over L naught V naught squared, square root, so we'll just take the square root of this and leave that like that, and take the positive root. So either way, we'll get the same value.